Hello, my name is RF, and I'm going to explain my project to you, which is about um, measuring distance and speed of an object with the help of a distance measuring sensor, like SRF04 ultrasonic sensor. So quickly, I'll go over my setup here. So here you can see that I have a breadboard, the Arduino, and the sensor. And these are the connections. So this sensor is a 4-pin sensor, VCC, 5 volts, GND, and trig and echo pins for this. Um, so when to visualize a barrier, I just use this cardboard, and I'm gonna go over how does the sensor work. So let me share my screen here. Right. Okay. So basically, the sensor is as a sound sensor. So Uh, there is a there is a transmitter and a receiver. So I need the sound to be the way the SRF04 works is it's just sending the sound pulse or signal to the forward, and just receives whatever when it receives the sounds by the receiver. So if you want to measure the distance, you have to you have to activate the trig pin for 10 microseconds, and then calculate the duration of time the echo pin, which is the receiver, receives the sensor. So this duration would lead us to have the distance. So, but first, let me explain how I did this. So I have here my sensor. As you can see, it just transmits and receives all those signals. Then I just wrote a program in IDE programmer, which is for Arduino basically, to do the thing I discussed about. So as you can see here, I define my pins like trig and echo, and I'll talk about this button afterwards. Um, so in for sending this distance, calculated distance, I need a serial connection between the board and the Arduino, as you can see in this picture. So I send the signal through the trig pin for 10 microseconds, and calculate the duration, and get the duration. I get back the sound signal. Um, and also, so this would be the calculation formula for the SRF sensor. As you can see, it just sends the sensor and it sends the signal and receive it back. The distance between the barrier and the sensor, it just the time or duration it took sensor from sending the track pulse and receiving it back from the echo. So for getting a distance, I just multiply this duration by speed of sound, and also divide it by 2, because that's one going and one coming back, um, a duration or time interval. Um, so after I just calculated this in the IDE environment, I send this distance as a serial connection to the MATLAB. Then I receive this distance and I process it in the program. And from there, I can graph the distance versus time, or speed versus time, um, graphs. So once more here in IDE, I just send the so and this button is just for the sake of stopping the program. If I just for starting and stopping the program, if I just click the button, as long as it would be on, as long as it would be released, the program will work. Um, so first of all, I just make sure my trick pin is off. So I just make it off for 2 microseconds here. And afterwards, I make sure and I send this signal for 10 microseconds and turn it off. That's it. Um, there is a command like the long and pulse in, um, which can actually gives you the duration of a signal through a pin, which I used it for the echo pin to see how much was this time. And here I applied that speed formula to get the distance. And finally, I just send this through the serial to the MATLAB. And at the end, I just use a delay not to overlap any data together. Okay. Mm, Let me close this and quickly show you how actually it works. Uh, Here in MATLAB, let me run it first and show you. Second. Okay. So here you can see I run the program. I start the program by clicking the button, and you can see two graph just pops up. Um, So in these two graphs, also just keep an eye on the command section because I can tell if the actual barrier is approaching or receding, is going away. So if I just move this barrier away, you can see that the distance versus time is just going upper and upper. If I moving it close to it, it's just going towards zero. So once more here. And for the speed, it's like how fast I just getting it close or moving it away. Like if I just do it really fast, like this, you can see there would be a peak in the speed graph. Also, if I just moving it away, you can see that it says receding. If I just getting if I'm moving it close to the sensor, it just say it's approaching. And this sensor is responsible for all of that one. Um, right. So let me go over the program quickly. Okay. So here it is the setup at the first of the program. I just do the serial connection setup. Um, I use the method we were using in the lab H for animated line. I used two subplots for the distance and speed versus time graphs. And also for removing the noises, I just used a moving average for the receiving for the calculated speed throughout the program. So here you can see I received the distance by readline command, which is the serial receiving command. I just put it as distance, like as you can see here, I can have the distance, I can have the speed and the object that the position, the situation of the object. Um, so I calculate the speed as I told you before, like time, the duration times the so the speed is different. I calculate the speed with delta x over delta t, and I just do it with this for with this function, which is at the bottom of the program. So the delta t is the difference between each time interval and the next when I'm just making when I'm having these samples, and basically I calculate the speed like that one. Also in the function, I have that moving average filter, which we used to use in Lab H for for reducing the noise we get from the microphone. And at the end, if the distance, so there is one for each time interval, there is this distance, current distance, and the previous one. So if the current distance is lower than the previous distance, it means that object is just approaching. And if the current distance is greater than the previous distance, it means that it is moving away. So I'm just having it in these conditional statements at the end, and updating the axes, like x-axis is like before that we is similar to before that we used to do it in the lab H. So for this program, I wanted to do a buzzer to specify the threshold speeds, like if the speed was greater than 15 centimeters per second, um, my buzzer will buzzing. But because of the time, I couldn't do that one. That's just basically the graphs, the XT-VT graphs. The That's the distance, that's the speed, and whether the object is approaching or moving away from the sensor. So basically, that was my project for um, bonus project. And yep, thank you so much for watching.